So, you are the Silicon Valley Director, Associate Professor, Entertainment Technology Center. You are a pioneer and computer animation specialist, creator, wonderful wizardry person for film and television. When you were a kid, what did you want to be when you grew up?
I wanted to, it's going to sound hokey, because I wanted to do what I'm doing, which is combine entertainment and technology. So I loved movies, and I wanted to make movies, and I did through high school on film and stuff, but I was also a really geeky kid. I loved my physics class and stuff, and so I somehow wanted to combine the two of those together. And I got to do it.
Awesome. Okay, question number one. Question number two. Your resume reads like a hybrid fairy tale / Wild Kingdom.
Cool.
From ants to Shrek, Shrek 2, Madagascar for starters. So inquiring minds want to know, do you prefer the fairy tale of ogres and princesses or talking penguins and zebras?
I actually liked the penguins and zebras. Although Donkey was pretty awesome. But the penguins are the best.
Yes. And you are an amateur musician in your spare time.
Yeah.
What are you working on?
What am I?
What are you working on? What do you play? What do you work on?
I play guitar poorly, but I have one that I built out of Lego that actually works.
Oh. Very cool. Very cool. You passed the test.
All right.
3 questions. Awesome.
Cool.
Everybody, Carl.
Welcome to the Silicon Valley campus of Carnegie Mellon University's Entertainment Technology Center. Yes, inside of Electronic Arts. We've been embedded here for just about 9 years now. Thank you, EA. Not God, I'm just executive. Okay, quick show of hands. We have 20 students here this semester. That's it. You can identify us because we're all still wearing our EA badges to get around the building. Okay, we also have a bunch of alumni from ETC. All right. Most of whom, but not all, but most of whom spent one of their 4 semesters, or maybe 2, here in Silicon Valley with us. You can stand up there. Or you can...
Hello everyone, welcome to this amazing event. First, I would like to introduce UI artist. This is Ferran, producer and 3D artist. This is Christiana, programmer and sound designer. This is Eric, programmer and game designer. Our advisors are Carl Rosendale and Heather Kelly. The client of this project is Entertainment Technology Center.
Chooses either a task track or a mission track. The task track includes 3 different types of.
Eva, the game designer and producer. At first, players can connect their mobile devices to the television by inputting URL or scanning a QR code. After that, the host player can make a selection for everyone, rainbow and screaming ball to add some flavor to the game. Chubby Duck is the game we developed after Hives. This game proved to be fun because players love to play a competitive 2 vs 2 game. In this game, there is a feeder and a duck in each team. So to win the game, the team need to raise their duck to 100 pounds. The feeder players are using their phones as joysticks to shoot bread to the pond to feed their own teammates and block the other team. The duck players are using their phones as joysticks to navigate through the pond and eat bread and avoid being hit. So after playing the 2 mini games, the winner gets to spin the fortune wheel and earn bonus tickets. Our system keeps track of
Right, so we are Team Internet, and this is our team. So we have John. I won't go through the description because basically the idea is to do whatever it takes to get the project done. So we sort of like switch roles quite a bit. So John, Eric, Laura, Brian, and myself, Vivek. And again, advisor is called Heather, and our client was called. So our objective this semester was to create an Internet of Things project that used embedded platforms like the Raspberry Pi and Arduino, and interacted with people. So we have some details about the hardware, which I'll probably skip, but if you're interested, definitely talk to us and we can give you the full details. And the software we use is also described here, but again, we can go over that in more detail if you guys want. We had some interesting challenges with just filtering noisy data and using a server to collect all of this information. So these are some pictures of people having a lot of fun with these boards in softs. So lessons. So first of all,
artist on the team. And this is Wei, experience designer, Jack, programmer, Sophia, UI UX designer, and Atit, our producer. Our advisors are Carl and Heather. And our project is about using augmented reality technology to solve real-world problems that can get the depth data from the environment and provide it to the mobile devices. And we developed an iOS application. It's called Pocket Room. And Pocket Room is a mobile application that allows the user to scan a room and bring it as a 3D model to a furniture store, so they can visualize how the real furniture looks like in the virtual room. And so why are we doing this? We have looked into many interior design applications in the AR technology, but most of them uses markers so that the user can visualize how furniture models looks like in the real room. But are you actually going to buy the furniture just because of the visualization? No, we wouldn't. Most of the people actually wanted to feel the texture of the furniture and actually sit on it before they decide to buy, especially for large furniture like a couch. So that's why we come up with this idea, and to let you bring your room to the furniture store and help you make a more informed decision there. So our goal is to improve the in-store large furniture purchasing experience. And we're going to show a quick demo of how it works. So first, you start by scanning your own room, which generates a 3D model that could be saved into the mobile device. And we also automatically improves the quality of the scan. Once you arrive at the furniture store, you can load your room by choosing it and selecting the furniture with the bounding box. And then when you replace the real environment with the room model you scanned, and you can move the room around using your finger. And then you can visualize how the furniture looks in your room. And you can also take screenshots and share it with your friends. Some of the lessons we learned is because there are a lot of technical constraints for ARs. And there's one thing is about loading the really high poly room model into the thing, and the user have to wait for a very long time for it. So we had this loading screen, also a confirmation screen, to include tutorials at the same time, so that the user can keep engaged while they can get educated. About performance versus quality. So either is to get a poor quality model.
So our basic idea is like two. One is the scan your room.
Did you do your own scan? Are you doing your own point cloud capture, or are you using Occipital's point cloud capture?
Occipital. You just use the bounding box and focus the room you want to. And now you can get, you can see how the chair looks like in your room, and you can also like move where's the location of the chair and see how it looks like. So it's this is a real-time scanning.
Okay.
And also, we also do automated the background calling as well. So you can see how it looks like in your room, and take photo.
That's cool.
So if you want to buy this and you just want to ask someone like ask why